Genau, willkommen zum zweiten Teil dieser Webinar-Serie zum Thema Etablierung und Enabling beziehungsweise auch die Befähigung entsprechend der DevSecOps im Bereich mit dem Fokus auf Kubernetes als Technologie. Heute sprechen wir über ein paar grundlegende Dinge in Kubernetes Sicherheit und wie wir sicherstellen können, beziehungsweise unsere Cloud-native Applikationen sicher gestalten können. Und zwar in der Agenda habe ich mir Folgendes vorgenommen. Wir machen einen kurzen Recap, sozusagen eine kurze Zusammenfassung. Was haben wir beim letzten Mal gemeinsam besprochen? Da werde ich versuchen, schnell drüber zu gehen, um euch einfach diejenigen, die zum ersten Mal heute dabei sind, auch einen Überblick haben, was haben wir eigentlich beim letzten Mal besprochen. Danach möchte ich gerne zu den grundlegenden Dingen gehen, zu zwei Fragen, die einmal zu den CIS-Benchmarks, also zu dem Center Internet for Security. Da gibt es unterschiedliche Standards für unterschiedliche Technologien, die vorgeben, wie man eine bestimmte Technologie entsprechend härtet oder sichert, so dass gewisse Anforderungen dann erfüllt werden können. Und danach auch zu einer Open Source Lösung KubeScan. Da werde ich kurz das Tool erläutern und dann eine sehr kleine Demo vorbereitet, die sehr selbstverständlich auch erscheint, auch sehr einfach ist zu nutzen. Warum habe ich das heute gewählt? Ist einfach, weil bei vielen Webinaren, die wir jetzt in dieser Zeit auch gegeben haben, stellt sich die Frage, dass entsprechend viele sich fragen, was machen wir? Okay. So, ich habe eine Bitte hier dass ein Attendee sozusagen sagt, dass er Englisch, das in Englisch haben möchte. Is there anyone that doesn't understand English? Because it seems that we have an English speaking attendee. So please, can anyone, if anyone here cannot speak English, please let me know. So if this is not the case, then I'll switch to English so that also our attendee here speaking English is able to understand what we're talking about. So let me start from the beginning then again. So today it's going to be only me providing the session. My colleague Alexander Torst, it's unfortunately unable to join, but nevertheless, I'll do it. And as I said, this is the agenda for today. I'd like to give you a short recap of what we are doing, of what we did the first time, and then we'll go to the CIS benchmark and then to KubeScan. Just a short introduction on that. I chose this topic because the first question that it raises is about new companies or startups or small companies that don't have the resources. Nevertheless, they want to establish and enable DevSecOps on their business and their projects. The first question that arises is how can we cope with such a complexity, and what is the best way to start, even though we don't have the much resources and much knowledge about Kubernetes. So where should we look first? And this is two things I would recommend, and this is why I chose them. One is the CIS benchmark, which we will get to know in shortly. The other one is KubeScan. I would like to introduce you also to KubeScan in a short demo. So this is the agenda for today. So let me switch to what we talked. The last time we talked about, I'll just put the title here. We give an overview of how we at Cloudical understand Kubernetes. So this was the topic. And my colleague, Alexander Trost, he was talking about why open source is important and how open source actually is to be understood, also from our perspective. And if I can cite him, hopefully correctly, the idea here is also open source. It's not only to take, but also to give. So a lot of things that we have as advantages from open source, we also should give it back, especially when we develop knowledge insight in the company, or we find problems into the documentation, and to give something back to the community. This is something we try to enforce at Cloudical. So we have this mindset. We like to share our knowledge. We'd like to provide our insights and to exchange, because we believe that improvement comes through exchange, and through being transparent and through learning from each other. Into that, I would like to go very briefly through what is our understanding about Kubernetes, or security in Kubernetes. I will very briefly go through the slides in here. I don't want to lose a lot of time on this topic. I will post also a link where you can find the video. I delivered this talk together with our partner companies Global Dots and Octarine. So you can have the full video on my talk and two other very smart and skilled colleagues, also giving insight in Kubernetes security. So in here we started with an agenda. We wanted to understand security and why a holistic view is important. And we started by saying that 99% of cloud security failures will gonna be customers' fault. So this is very concerning prediction. So you have to make sure that you are using the cloud, but you don't want to be blamed at the end of the day for any issues, security problems and challenges that you are going to have. And sure, you are going to have security challenges. And if you go to Kubernetes, you will find this definition saying that this is an open source system. It manages the deployment, scaling, and containerized applications, and it automates those. But de facto, Kubernetes is a cloud operating system for the moment. It can undoubtedly call like that. And we know for a fact that operating systems are very complex, and we know that complexity is the enemy of security, and we know that the more code we have, the higher is the probability that there are errors. And we know that these errors, as shown in these examples, or these flows you might call, can be not found only in very complex constructs as operating systems that have millions of lines of code, but even in a 5-step protocol, as shown here in the Nedam-Schroeder protocol, where you have only 5 simple steps, and you have a vulnerability of replay attacks, and this vulnerability was only found 17 years later after the protocol has been published. So you have to be aware that security challenges or problems can arise even later in time, even when you think that you are going to be, you are secure for the moment. So security, it's not, let's say, a single point in time. At this moment, we can say, okay, is it all lost? Should we give up security? And here I would really recommend you to listen to the talk of Robbie Joycey, Chief Tailored Access Operations and at NSA. He was talking about disrupting nation state hackers, and the takeaway messages here: know your network, know your devices, and know your security. But what is security? So you have to understand what security is in the first place, and understanding security is, and you don't want to be in these urban legends, because it's not uncommon when you talk to people about security to listen or to hear statements like, no incidents ever happened to us, our network is secure, and our employees are trustworthy. So security, to understand it better, we need to understand what goals it aims. And here are the most common ones, which is the confidentiality, which is the practice of concealing secrets, integrity, the practice of making sure the data has not been modified authenticity, making sure that the person in the protocol is the person it claims to be, so you are able to verify, or the origin of the data. So you have to distinguish authenticity in two parts. And availability, which it means that principals can get the services, or legitimate principals, I have to emphasize here, can get these services at the time when they need them. And there are many more, but these are the most common ones. And we also come across of the term information security, and most of the people don't really understand what actually means information security. And information security, it has not only something to do with technology, but also with information. It's about protecting information, which you can store on paper, which is stored on people's head, and also on computers. Cybersecurity, in contrast, it adds to that the technology, the communication technology. So when we talk about cybersecurity, we are not only protecting information in terms of information security, but also widening our horizon into how this information is being communicated. So very important, security is not a product, it's a process. It's a continuous, integral, multi-layered and multi-dimensional process. It comprehends technology, people, environment, and the interactions, and an holistic view. So if you go to Kubernetes security website, or to the section where they talk about security, you will find this very high-level view, and you see the four C's of native cloud-native security. But it's important to understand what lies behind this. And if you look at this picture, it gives you an architectural overview of what this actually means. And starts by the governance, it goes to the facilities, to hardware. You have to think about the hypervisor and the host operating system, the container management, which is powered, let's say, by Kubernetes here. It has the same questions as the operating system, as I mentioned before. You have to think on the network level about segmentation, secure protocols, security tools, for example, EDS, EPS. On the application and library level, you have to think about authentic versions, secure programming languages that enforce types, for example, like Java in comparison to C. Software patterns, which enable you to find bugs or to debug applications very easily. And next is the clients. You shouldn't forget the clients, because these are the doors to your environment. So these clients also need to be somehow secure, because if these clients are not secure, you are gonna leave them enter your environment. And last but not least, also the users, so which are the weakest link in the security chain, as we know. So we need to make sure that people are continuously being educated, but not only about being aware of the security challenges that are out there, but also behaving secure. This is very important. And that they are using, for instance, strong authentication, and they are tools enhancing their behavior and supporting them. You have to think all of this in a DevSecOps. Let's say that integrate it into a life cycle. As I said before, this is a life cycle, this is a process, and cannot be seen only as a product. So it's your duty or your responsibility. So depending on our computing model, you have to understand where your responsibility starts and what action you have to take. This is a very late, very new attack matrix on Kubernetes, brought out by Microsoft lately. I think it was the beginning of April when this came out. It's a very nice overview to understand your attack surface and to implement adequate detection and mitigation measures. And again, so this should show, like, don't do this at home. So please, addressing some security requirements, some specific challenges. It's very important, but nevertheless, to achieve and to maintain a security level, an adequate security level that you need at your company, you have to think holistically, and you have to address security in broad terms. So this is it about how we understand security. I hope this didn't take us too much time. Let's go to the next one, which is the CIS benchmark. If you go to the CIS benchmark, so I'm not able now to to give you a full screen view, but I hope you can still read it. Can anyone please in the chat write a comment if this is good readable? That would be very nice to have that feedback, so that I can continue focused without thinking if you are reading this or not. Okay, that's nice to know. It's readable. Thank you for that feedback. Yeah, as I said, the first place where you can go, for example, you would be in a company you don't have much of resources, you don't have much knowledge, and I would really recommend you to go to the Center of Information for Security. There you would find a lot of benchmarks for different technology, and of course also for Kubernetes. The latest version that was out there is the 1.5. You will find this in a kind of PDF and not very structured as I structured here for us, and for us as a company as Cloud Eagle. When we start talking to clients, you need to have a systematic view on that. So I created this Excel sheet, even though I hate Excel sheets, but I mean, there is no other opportunity or option to use something better for the moment. So, but it's still valuable, and it can still make the task. We don't want to complicate things. As we said, complexity is the enemy of security. So let's start, for example, when you look at the API server, you would have different themes on the API server. For example, how you deal with access control. So the API server is the central component of the control plane in the Kubernetes environment, and you want to make sure that not everyone gets access to the API server, and the ones that get access are, for example, authenticated, that they don't use, for example, let's say, not very secure authentication mechanisms, and so on and so forth. So there, for example, you would have security controls, so ensure that the anonymous authentication argument is set to false, and you would have a rational saying to you that you have to disallow anonymous requests, and if you are using airbag authorization, is reasonable to consider or to allow access to that. Nevertheless, you should be aware of the risks. So what are the risks that you are settled? Because at the end of the day, it's about risk analysis, risk assessment, which we are going to get to know into the next part with respect to KubeScan. So let's see the next topic on the API server, for example. So you have here, as you see, a lot of configuration settings that you can use. For example, here, ensure that admission control plugin pod security policy is set. Yeah, so you are able to use pod security, and with that, to control the security features a pod has access to, and it used to what permissions the pod can have, and you can understand this, or let's say narrow or tighten the security configuration of your pods into the environment. For example, you can use like node restriction, where you can set that the kubelets will only be allowed to modify their node API objects, so they are not able to modify objects on running on other nodes. So there are a couple of important things. What is more, again, important in the first place, on the Kube API, you will have, for example, encryption in transit. So what you have to make sure here, for example, is that the secure port argument is not set to 0, so that you are using the secure port to connect to the Kube API. So you are using encryption in transit. Let's say you are using TLS and certificates, and you have to make sure that the files of the certificates, like the TLS certificate file and where the private key file are set as appropriate, so that they can be identified and can be found. So you want to use that is possible to talk to the API only in a secure manner. So imagine if you don't do that, anyone that is sitting in the network, anyone that is in the same, let's say, namespace, and has access to the network and has network capabilities, it would be able to listen to the traffic that your pods are communicating. And imagine, for example, you would have, let's say, different pods running on the same namespace that don't need or shouldn't have actually access to the communication. And this is how you can secure this here. And there are many more also here in this sign. For example, here with the etcd, which is, let's say, the heart of your Kubernetes environment, where all the state of your cluster is stored. And if someone messes up with this database, then you can imagine that things can go very, very wrong. So in order to access this, you request the API server to identify itself before it accesses the etcd, the key value storage of the state of your complete environment. So let's go further. Encryption at rest, also very important on the Kube API server. So you don't want things to be stored on plain text. So here you have the possibility to use, for example, IS with CBC as an encryption mode. Would allow you to use symmetric encryption and to encrypt your file system in order so that anyone not having access, or anyone having somehow access to that file system, because we know no 100% security is there. Any bug can be there, and someone can access it still, and he's going to not be able to do that and to access or to read the data, at least. Hardening the API server, you have here again a couple of configuration possibilities where you can that you can use. For example, to make sure, depending, of course, on your context. I'm not suggesting here go on and implement all of them. You, of course, need to evaluate which of them makes sense to your context. Most of them are to be recommended. Nevertheless, in a let's say in an informed way, you need to think how you do this in order to not let's say restrict your developers in that sense. So let me go to logging, for example. Yeah, one thing about security, as we were talking, Kubernetes, let's say, is the cloud operating system. You have to think about logging. As you think in the operating system, you have to think about logging, and here you have the possibility to log. So you need to set the path of the log. You need to have the time, what time you can investigate. So what is the maximum age that you need to actually retain the logs? So this is coming probably from the requirements of your company. You can back up the logs and so on and so forth. So separation of duty is also a topic. Another component that is also important is the scheduler. And here, if you look at the CIS, you have a couple of different configuration settings that you can use for hardening the scheduler. The next one is the control manager. And here, for example, you can only address access control in the control manager and ensure that, so that the control manager creates a service account for each namespace. And you don't use the default service account and access all all of the namespaces. So again, thinking about access control, thinking about the principles of need to know, least privilege, and separation of duty. These are three basic principles you also always have to think about it from a security perspective. Availability, so what you can do for availability, because this is also a very important point I want to emphasize here. Availability, we tend to think that, of course, Kubernetes take care of the scaling, and I mean, if nodes fall down, they are going to be started up automatically. So what actually are you talking about availability here? But here it's about the garbage collector and when pods are terminated. So if you ensure that the terminated pod garbage collector threshold is set as appropriate, and you have to understand what is appropriate for yourself. You need to understand this from the resources that you have, let's say, that are available. You need to set the appropriate value here. Otherwise, you are gonna, let's say, degrade the performance and the availability of the cluster. And this is something that you don't really want, because you are pushing Kubernetes also into your environment and discussing maybe even with people that were using traditional way of technology, that you are pushing this also by emphasizing on the availability of it. Encryption in transit is the same, and you can do some hardening stuff in here, and configuration files. This is very important. So here in the configuration files, so we know Kubernetes is a lot of configuration files you can set up, and you can set, for example, the permissions. You can set, for example, the API server specification file set that is set to root. And so on and so forth. So you want to set this more restrictive. So I won't go again into details here. So let me go to the next topic actually. So we are mostly have a good overview of this. Let me go to the next topic, if this would allow me. Yeah. So what is KubeScan? I also go very briefly on that. So KubeScan is a risk assessment with Octarine. Octarine is a company, as I said, a partner we are working with, and KubeScan is for free. It's open source. You can use it, and it will give you a good overview what is the current state. Yeah. So we are talking about only current state. We are talking about what is your posture now. It won't give you the possibility to continuously monitor, but it's still a good start. It still helps you to understand the basics, the fundamentals of security, and what can you do to improve security. Let me go very fast through it. So why Octarine? Octarine is an Israeli cybersecurity company, and why security is so they focus on Kubernetes, and it's very important to understand why Israeli companies are very good in the security when it comes into cybersecurity, because as you see in this small little picture, you have a very good ecosystem dealing with industry, military, governance, and academia. So they are putting this all together, and then by putting all these smart heads together, of course, you will get a lot of knowledge out of it. So KubeScan, is an open source. It's a single pod deployment. It contains a scanner, scoring engine, and a web UI. It has risk score for each workload you run on your cluster. The scores are based on your runtime configurations, and it introduces a new a scoring system called the Kubernetes Common Configuration Scoring System. The security configuration include, for example, privilege levels, capabilities, and configuration are assessed not solely, but in combination. And assessment criteria are easy of expectation, impact, and scope. We will see this in the demo. Now you are at risk. So this is where you install, run, and you find that you are at risk. So what now? You need to understand the risk landscape. Evaluate the risk not only solely, but also in combination, and use this, for example, the attack matrix from Microsoft would give you a standardized way of talking and having a common language, which is also here important. Prioritize your risk and define adequate treatment strategy. Who is the enemy? Anyone with specific knowledge. Octarine 2, no, this is not the case because the data doesn't leave your cluster, so don't be worried about that. If you also have requirements with respect to data privacy protection, so the data doesn't leave the cluster. Let me go to the demo because I think we are also a little bit in a hurry with the time. So are there any questions so far to that, what we talked about? So I need to copy this. So now we have the correct credential. And hopefully can connect to our lab environment. By the way, in the meantime, I can point you to the following video. So I need to find the chat. So there you have this this webinar we held together with our partners. So I was kicked out because I didn't use it for. Let me try again. Why is this copying this so? Yeah, so we are back on that. So it seems that the logging is working. Can you see my screen? Can someone, can you see the Ubuntu machine? Is this what you are seeing now for the moment? Can someone in the chat? Yes, okay, perfect. Yeah, so here, for example, I've installed the micro. It is, and as you can see, so I don't have here in the services the KubeScan, but it's very easy to to get it, to install it, and with only one, I was doing this before, so let me just use this one. So this is the only command you would need to apply this pod. If we look at the services, you will find out that KubeScan was installed and you can use the cluster IP to access it. So let's put a 0 in here. And here, then directly you see there, so there were two containers running in here, as you can see on the dashboard. So one is the hello world and the bootcamp. I really just some examples for you here in this very small demonstration. And KubeScan, as you can see, it already identified them and it gives you a risk. So when you go in here, it will show you what is the risk. So it will give you a score. As I said, the scores are from 0 to 10, depending on the risk level. It will tell you what is the resource, the namespace, and what kind this is, and is a deployment. For example, in here, you will have medium risk workload may have containers running as root, and you would have an explanation telling about what is about integrity. So you'd have, for example, a low impact on integrity because, yeah, container running as root may be able to escape their container and perform malicious actions. Confidentiality is here high level, availability low. I mean, these are only suggestions for sure, and this depends, of course, on how these values are provided. And this is what Octarine is suggesting or is recommending. This is open source. You can take it and implement your own. So you can customize this by yourself if you want. But as I said, this would give you only one simple overview of what's going on into your cluster, and it will help you understand. And it will give you, for example, even a description saying that if workloads do not specify an root user and run and does not specify the the setting run as not non-root user. And here, for example, for companies that don't have so much knowledge about it, they can directly identify, okay, what is the problem? And they can, for example, I would say Google it and get more knowledge and be more specific, more pragmatic. So this is a way of doing security in a pragmatic way when you start and you want to do the fundamental things into securing your cluster. What else it says? For example, workload has net row capability, so it can listen to the network. For example, the container which is CPU or memory limit was not configured. You would have a problem here, a very high availability impact, because if you don't set up CPU memory limits for your containers, they will then, if a malicious container or malicious pod is there, it would, yeah, let's say, get all the attention of the CPU and will DOS your environment. So you will be not able to use your environment anymore. Yeah, so this was about the first one, and the second one you'll find very similar recommendations. Um, yeah, so this is it. This is how you can use KubeScan. These are the fundamentals I would recommend with respect to how you can do security in a pragmatic way on Kubernetes. Um, as you could see, this was only one very simple command. If you want to delete it, you can delete it, and it's gone. So no data is there, no pod is running anymore. And one thing you have to keep in mind is that when you run it once and then you install again, and let's say a new container or new pod, a new application, KubeScan is not going to be able to identify, but you need to restart the to delete it and install it again so that it will give you an overview of the security posture you had so far. So with that, I'll thank you for your attention, and I would be glad to answer any questions if there are any, or suggestions from your part, or things that you would like to see maybe in the next time. What security compliance benchmark it is built on? I don't quite understand the question. What do you mean by that? What is built on? What do you refer by it is built on? What do you mean by that? Which security definitions it inherits these definitions of security? Um, Unfortunately, I don't quite understand the question. So what do you referring? You're referring, maybe you can say, are you referring to the benchmark part, to the CIS? You have a specific question in that, or are you referring to KubeScan itself? For the scan part, yeah, okay. So the scan part is, as I was saying, it introduces um, this configuration, Kubernetes common configuration scoring system, and this is where it builds on. So this is where it actually it is defined. And if you go to the website or to the GitHub, let me show you. Um, Here. So here you find all of this pre-configured definitions with respect to security or configuration that you need to do. Okay, I understand your point. So this is looking at CIS benchmarks, but it also includes best practices in general. So it's not only CIS, it's also knowledge that comes from every day. It's not only looking at CIS. So it tries to cover a lot of security standards that focus on the Kubernetes, but it focuses only on the Kubernetes level. And the CSI, like the CSI star, it's anyway it refers to CIS, so that's why it doesn't make any difference there. So are there any further questions or any other suggestions from the attendees with respect to what is their experience maybe into dealing with fundamental security stuff or challenges in Kubernetes, and also on topics that you want to look more inside within with that? Okay, so it seems that there are no other questions or open questions. Okay, so another question comes. So bear with me. Managing the scans for big deployments is challenge, and also the reporting. Yes, I mean, I would say it's always a challenge into managing the scans or the reporting. It's not related to KubeScan itself. Nevertheless, I would recommend here. So this was only, let's say, the starting point. This was the fundamentals where you have not a big knowledge about Kubernetes, you don't know about much about the security, where you have to change things, or where you have to configure your security into the environment. Of course, if you have a big cluster and if you want to have security, as I was trying to put into the beginning, into the recap of what we did last time, it's about thinking holistically about it and thinking about security as a continuous process. So KubeScan will give you only a snapshot. It will give you the possibility what is the current state. Your current state, it changes 1 second later when a new attack arises or a new bug is found out. So for that, you would need a solution that will give you, for example, a runtime security, looking at the configurations on runtime, auditing them, comparing them with different with your policies, and trying to identify if you have any escalations or any policy, let's say, violations. So you would need that. Yes, there is, as I said, there is the Octarine guardrail that is from the same company. They are looking at it from, so this is, they open source that. They open source the scanning part, of course, but this scanning part, and they have a solution. I would, um, yeah, so I would point to you to go to the web page and to look at it. Um, if you are interested, just contact us because we are partnering with them, and we can discuss your current situation and how you can use their product in your environment. Um, in order to have this continuous security into your environment and to have, for example, an intrusion detection system, a policy enforcement there, and also giving visibility. Because for the moment you saw only what risks are out there. You would need what you would need for a team that is working in a sense that are trying to secure your cluster or your clusters, because Ocarina is also working on the Istio service mesh, building up on it. It will give you the possibility to secure all of them at the same time, and the visibility of it. So you would see what pods are communicating from which namespaces and how the security policies has been enforced. It recommends you security policies. So it is completely another level. So Other questions? Okay, so it seems that we don't have any questions anymore. A couple of attendees have already jumped out of the webinar. It's understandable because we are, yeah, over with the time we were planning. Nevertheless, I thank you for your attention, and I would be happy to see you in 2 weeks. There, my colleague Alexander Trost will be also, and together we would address other topics with respect to Kubernetes security. We are going step by step, giving the understanding, giving you this possibility, and maybe we'll provide you also an overview with Octarine, with the runtime solution. So you are welcome to join. As I see that there's interest, so it makes sense seeing now that solution also as a demonstration and seeing the difference between that and KubeScan itself. With that, I thank you and I wish you a nice day.